So now we are in lesson 7.1 in chapter 7, integration as antidifferentiation and definite integrals. What does it mean, integration? Also, sometimes we can use the word antiderivative. So we will start by the introduction. You know already from the preceding chapters what does mean derivative and how do we do the derivative with respect to a variable. So if I have, for example, I need to find the derivative of x squared with respect to x. So derivative of x squared with respect to x, it's 2x. The integration or the antiderivative, it's the inverse step. I have the answer of the derivative and I want to know what was the function before doing the derivative. It means I can write this sign here like the S when I do it like this one we read it is the integral or the antiderivative of 2x, and this dx here it's written because I'm doing the antiderivative with respect to the variable x. So if it was, for example, 2t, I would write dt. If it was 2y, dy. So the integral, the sum of the integral and dx or dy or dt is all the time they are together. So we read integral with respect to x of 2x, so it's x squared. I have another function. If I take, for example, x2 plus 3, the derivative is also 2x. In this case, what's going to be the integral of 2x? The x is x2 plus 3. So what I can see here, guys, so every time I'm doing an antiderivative, I need to be careful that I might have a constant here because the derivative of a constant is 0, so I cannot see it here. So every time I'm doing an antiderivative, I need in the end to add plus c as the constant. And later on, you will see how I can find this constant by, they will give me, when we are doing the application, they will give me an information to help me to find this constant. Later on, we will see that sometimes there is a born here. We'll see it in this lesson. Why do we have a born? So now we have some formulas. So if I'm doing the integral of x and dx, so the formula is xn plus 1 over n plus 1 plus c. If you notice in the derivative, the exponent becomes times and it's minus 1. In the antiderivative, the exponent becomes over and it's plus 1. And also we need to remember to write plus c. If there is a constant, the constant is still there. There is we don't have any problem with it. So it's kxn plus 1 over n plus 1. Let's do an example. The antiderivative of x squared dx, 2 plus 1 is a 3, so it's x3 over 3 plus c. If you want to check your work, do the derivative. What's going to be the derivative? It's a 3, x squared over 3. 3 and 3 simplify, so it's x squared. And the derivative of the constant is 0. If I have the antiderivative of 2x3, also it's 2 integral of x3 dx, so it's 2x4 over 4 plus c. You can simplify, and then also you can do the derivative to check the answer that it's 2x3. Now another example, if you have a sum of many monomials, 2x squared plus 3x4 minus 2, we can separate each one by itself. Be careful, guys. If there is a plus or minus, we can separate. But if it is multiplication, for example, it's 2x squared, let's say, times 4x minus 1 squared, we cannot separate. We cannot do the integral of 2x squared times this one. We'll see later on how we will do if I have a multiplication. So integral of each one by itself. Integral of 2x squared is 2x3 over 3 plus 3x5 over 5 minus 2x. Why it's minus 2x? Here when there is nothing, what does it mean there is nothing? It means here as I have x exponent 0, it's 1. So it's x exponent 0. So 0 plus 1, it's 1 over 1. So it's x plus c. Now, we know that the derivative of sine, it's cosine. So what can I deduce? The integral of cosine, it's sine x plus c. The derivative of cosine, it's minus sine. So what's going to be the integral of sine? It's minus cosine x plus c. And the derivative of tangent x dx, it's secant squared, or also it's 1 over cosine squared. So what can I deduce? That the integral or the antiderivative of secant squared, also of cosine squared, 1 over cosine squared, is tangent x plus c. Example, if I need to find the integral of x plus sine x dx, I can separate. There is a plus. Integral of x, x2 over 2. Integral of sine, it's minus cosine and plus the constant. Also, if you do the derivative, 2x over 2, it's x. Derivative of minus cosine, it's sine. And then I will have the answer. Now, if I have, for example, another example here, I can have another variable. No need to have x. I can have theta yt. So here I'm using theta. Theta squared minus 2 tangent squared theta d theta. Integral of theta squared d theta, as I'm saying, x squared dx, so it's theta 3 over 3. Now, I don't have the integral of tangent squared. I don't know it. But I have a formula. You know that tangent squared, it's secant squared minus 1. And then I will separate. So it's going to be minus 2 secant squared plus 2 d theta. I forgot here the d theta, guys. I need to have d theta. So what is the integral of secant squared? It's tangent. So it's minus 2 tangent plus integral of 2 d theta. It means 2 theta plus c. Now, I have also sometimes a big expression and I need to do the integral. So I need to do it by substitution, or also we say by changing the variable. What does it mean? Let's do the example. If I want to do the antiderivative of the integral of 5x minus 4 exponent 7, I cannot develop here because it's a very huge exponent. If it was squared, I can develop. So in this case, I need to change it to the form of it's an expression squared. It's an expression, sorry, with an exponent. So it's integral of an expression as du. But how are we going to change into this one? So this expression, I will change the variable. I will say let u be 5x minus 4. And then I do the derivative. What's going to be du? It's 5 dx. In the expression here, so this one gonna be u, excellent. And by what I need to replace dx? I need to replace it by du over 5. So now what's gonna be the integral? It's gonna be the integral of u7 du over 5. When I say du over 5, I can even write it like this, 1 over 5 integral of u7 du. And now, what is the integral of u7? As I'm saying x7 dx, it's u8 over 8. So it's going to be 1 over 5 u8 over 8 plus c. And then I change u by the expression. So it's going to be 1 over 5 times 8 is 40. u8, so I will write it 5x minus 4, 8 plus c. And this is the integral of this expression. Now let's move to another example. If I have tangent squared, 5x minus 1 dx. So tangent, also I don't have the integral of tangent squared. I need to change to secant squared minus 1. So I know that tangent squared theta, tangent squared x, it's secant squared theta minus 1. So I will change in secant squared theta minus 1, or the expression. And then I will separate the integrals. The integral of minus dx, it's minus x. Now secant squared, it's an expression. It's not secant squared x dx. So it's secant squared an expression dx. So I need to change the variable. So let u be 5x minus 1. What's going to be du 5 dx? So instead of dx, I will write du over 5. So what I have here? I will have integral of secant squared u du over 5 minus, here already we did it, x plus c. Now the over 5, I can put it outside. It's going to be 1 over 5 integral of secant squared u du minus x plus c. What is the integral of secant squared? It's tangent. So it's going to be 1 over 5 tangent. And directly, what is u? I can replace it 5x minus 1 minus x plus c. Now the last part, and this is very important. Why do we use the integral? What is the objective of the integral? How do we use the integral? So if I have, guys, this function here, I have the blue function here. It was like this in the beginning. And I need, guys, to find the area of this green part here, this one. If you look at the figure, if this point is x, and I have here a distance h, so this one's going to be x plus h. I will name the area of the blue part here, this one, it's ax. And the area of all this one here, the red part, is ax plus h. How are you going to find the area of the green part? It's the subtraction of the two areas. It's area of the big part minus the blue part. And I'm going to try to bound, or to put the value of the area of x plus h minus ax between two functions here, or to bound it. So let's move to this part here now. So I will take this part here, the green part, and I draw it here, guys. If you look at this part here, it is bigger than the red rectangle here. If you draw the red rectangle here, it's bigger than. What is the area of this red rectangle? So the area of the blue part is bigger than this area of the red rectangle. It's length times width. So it's f of x times h, because this is here the y is f of x. And If I draw the big rectangle, the yellow one here, that has a length x plus f of x plus h, it is less than h times f of x plus h. So the area of x plus h minus a of x is between h times f of x and h times f of x plus h. Now h is a constant, so I can divide the two parts of this inequality by h. And now, when h is tending to be 0, when I'm moving h to be 0, so if I'm moving this till this part here, what will happen to f of x plus h? It's going to become f of x. And here when I say when h tends to 0, so here as I'm doing the limit of a of x plus h minus a of x over h. Where did I see this before? We saw this before. What does mean the limit of a of x plus h minus or f of x plus h minus x over h? It's the definition of the derivative. It means f of x is equal the derivative of the area, because this is the function here, we name it a of x. So what can I write here, guys? I can write that f of y, I wrote here f of x is equal because the limit is between f of x from the two parts, so it's equal to f of x. So what does it mean, guys? It means that f of x is equal to the derivative of the area, so area prime of x. So it means f of x equal d of a of x over dx. Now how can I find the area? If you cross multiply, you will have d of a of x equal f of x dx. So I need to do the integral on the two sides. What is the antiderivative of the derivative? It's the area itself, and it gives me the integral of x dx. So this is the proof, guys. This is a proving. You don't need to um, to do the application for this one, but here I'm proving for you that why do we use the area? We use the area. How do we you find the area? We use the integral. So we use the integral to find the area bounded by the curve, the x-axis, and two vertical lines. It could be between two curves. How we will see how to find it. So let's do an example. So in the end, so what is the area? The area, it's the integral between the two vertical lines here, a and b, of the function f of x dx. And when after you calculate the integral, you find the answer. You do f of b minus f of a. So you replace by the upper boundary minus the lower boundary. So if the function was below the x-axis, so you find the integral of the absolute value of f of x dx. Also, we will see another formula, it's upper minus lower. Let's do an example, guys. So if I have, for example, this triangle here, and I need to find the area of the triangle formed by the x-axis and the two lines. I have the first line, this is 2x plus 4 and 4 minus x. First, if I want to use the formula of the area of a triangle, it's base times height over 2. What is the length of the base? It's 6. The height, it's 4 over 2, so it's 12 units. Now, if I want to use the integral, I need to divide it in two parts. So I need to find the area of this part here plus the area of this part here. So the area is going to be the integral between what and what? Between minus 2 and 0. That's it. Upper boundary minus the lower boundary. This is the upper. This one, it's 2x plus 4 minus, this is 0. Okay, plus the integral between 0 and 4 of the upper minus lower of 4 minus x minus 0. And then you do the integral and you replace. It's a normal calculation. So I will find the integral of 2x. It's 2x2 over 2. So it's going to be x squared plus 4x. There is no plus here because there is a boundary. And then you replace by 0. It's going to be 0 minus. Then you replace by 2. It's going to be 4 minus 8. That's it. Plus, also again, we replace upper minus lower. 4 times 4, it's 16 minus 8. Minus, so this one is the, when we replace all the expression by 4 minus by 0, then we will have the same answer. Let's say I have this figure here, and I need to find, this one represent x3 minus 2x squared minus x plus 2. And I need to find the area of the shaded part here in the figure. If you notice here, I have one part above the x prime x and one part below. So I need to cut it in two parts. So the area gonna be first between minus 1 and 1 plus the area between 1 and 2. Now, in this part here, since the function is below x prime or x, either I will say, guys, it's the integral of the absolute value of f of x dx, or I can use the formula, it's the upper boundary minus the lower boundary. So the upper boundary is 0 minus f of x. So either you do the integral of between minus 1 of f of x plus the integral between 1 and 2 of absolute value of f of x dx. And then you see how we'll do this one. Or you do the integral of between minus 1 and 1 of f of x dx minus the integral between 1 and 2 of f of x dx. So I will do is the absolute value. And then you do the normal integral of this is f of x, x4 over 4 minus 2x3 over 3 minus x squared over 2 plus 2x, plus absolute value of x4 over 4 minus 2x3 over 3 minus x2 over 2 plus 2x. And now I replace x here by 1. So it will be 1 over 4 minus 2 over 3 minus 1 over 2 plus 2. It will give me 13 over 12 minus, we replace now by minus 1. This is the answer. Plus absolute value of, we replace by the upper boundary 2 minus, we replace by the lower boundary 1. Here I will have the answer minus 5 over 12. I cannot have a negative area. That's why we took the absolute value. And then we will add the answer is 37 over 12. Even if you did the second method by saying here it's minus the integral of x, you're going to get the same answer. Sure, guys, we're going to do more application for this part in the class. See you next time in the next video.